This is SoundStage founder Doug Schneider. You're listening to the SoundStage Audiophile Podcast, your semi-regular deep dive into news, facts, opinions, and anecdotes about everything that really matters in the world of high-performance audio. Hosts Brent Butterworth and Dennis Berger have more than 5 decades worth of audio product testing experience, and a few hours of podcasting experience as well. Now, here's Brent and Dennis.
Hi, everyone. It's Dennis Berger, editor of SoundStage Access, a website dedicated to high-value audio and also tips and tricks for people who are new to the hobby.
And this is Brent Butterworth, editor of SoundStage Solo, which is about headphones.
We both write for the SoundStage Network, which is a collection of 9 sites dedicated to all sorts of different areas of the audiophile hobby. We've got, totally high-end sites. We've got sites that focus on sort of digital connectivity. We cover the whole spectrum.
And we are going to be talking about a wide range of audio topics today, including, Dennis, what is our first topic you would like to discuss?
I want to dig into this article that you just wrote on SoundStage Solo about David Chesky's new album. So you've got an article called David Chesky's New Revolution in Headphone Sound. I want to dig into that.
Okay. And then we're going to talk about Dirac introduced a new live auto target curve. And, Dirac makes these things, this technology that automatically analyzes your room acoustics and corrects for it. I don't know a lot about it. I haven't used these things for years because I mainly review headphones now. But you, Dennis Berger, are what I consider to be probably the top reviewing expert on this stuff. So you're going to explain to us what this means and tie into your review on SoundStage of the NADC 399 integrated amplifier.
Last up, you sent me an article from Audio Express that I want to dig into about GaN FET amplifiers, sort of what advantages they might have. I think we're going to be hearing about GaN FET a lot more in audio. Yeah. So I want to dig into that. Also, there was an article on Audioholics that you sent me about the same subject. Peachtree Audio has a new GaN FET amplifier. So we're going to talk a little bit about GaN FET, what it means, and I'm going to be asking you a lot of questions because I honestly kind of don't fully understand it.
And I will be making up some convincing sounding answers.
Okay. Before we get into that, though, let's talk about this piece that you wrote for SoundStage Solo, David Chesky's new revolution in headphone sound. Why are you writing an article about a jazz album, man?
Well, first of all, jazz albums are the best albums. And but second of all, so David Chesky, for those who don't know, David Chesky is one of the co-founders with his brother Norm of Chesky Records, which has been for, I guess, about 40 years, putting out audiophile-oriented recordings. And I really love the Chesky records. He's gone through all sorts of evolutions. David's very kind of restless in what he does. He did a lot of binaural recordings when headphones were getting big. And now he has started to do a thing called metadimensional sound. Now, this comes like so many albums these days. This comes out of him being stuck inside during the pandemic and not being able to play gigs and not being able to do. I mean, Chesky normally records with a couple stereo microphones in a big ambient church, and you've heard this stuff. It gets spectacular ambient sound. It's really incredible, but he couldn't do that anymore. So he tried to figure out what he could do with a digital audio workstation like Pro Tools or Apple Logic or whatever, and to try to get some of those same effects with that using only instrument samples. And so what he's done is he actually has, for the $9.99 download, you get a mix that's targeted towards headphones and then a mix that's targeted towards speakers. So you can listen to it 2 different ways. And they're not necessarily subtly different. No. I mean, sometimes there's actual content changes.
Radical changes.
Yeah, sometimes he put different instruments and different sound effects in the mix. So from an audiophile standpoint, I think it's an absolute must here. Everyone should go to, Chesky. What is it, Chesky.com?
The new site is the Audiophile Society, right?
Oh, thank you. Yeah, it's thank you. I forgot. He started a new site called the Audiophilesociety.com, which is a little more, a little kind of, I think he's targeting a younger audience, and it's kind of a little more fun. But for $9.99, you get this download, and it's really, first of all, not only does it sound really cool, I mean, every audiophile needs to hear this, but in my personal opinion, I just think David Chesky is one of the most interesting jazz artists right now. And the music is an extension of what he's been doing for about the last 10 years, which is more like even though he's a piano player, kind of getting away from a lot of chords and just using like bass lines, melodies, and percussion. And it's real sparse, but it's really cool. It grooves really hard. This is not some airy-fairy jazz stuff, and it's not like some sax player going. It's really cool. Like it's got a lot of melodic. It's very melodic. It's got a lot of groove. It's got a lot of fascinating effects in it. It's kind of a weird mix of jazz and electronic dance music, and I don't know what. But I just think from a musical standpoint alone, this would sound great in mono, okay? But to hear it in Chesky's new kind of sound experimentations he's doing, it's way over the top interesting.
I have to say, we need to just put this out there for everybody to put my comments in context right off the bat. My tastes in music are not very sophisticated. I've always admit that, and I'm not a really big jazz fan. Honestly, my favorite jazz musician is Vince Guaraldi. So that should give you a level of like how mainstream I am in my jazz tastes. I don't know if I would have listened to this album if you had not sent it to me and said, hey, we're going to talk about this. Man, I'm super glad we did, because I don't necessarily have the jazz vocabulary to explain why I liked it and what I'm hearing in it. But my experience with the album is sort of like my first experience with Tool's Anima, or even something like Herbie Hancock's Headhunters. It was like with Anima in particular, one of the first things that grabbed me was that, well, they're using guitar as a percussion instrument. And with Headhunters, there was all of this sort of weird sound textures brought in and made musical. Or you could even compare it to something like The Comet Is Coming, which is, I guess, one of the few sort of modern jazz acts that I really love. But this album, again, please keep in context, I don't have very sophisticated musical taste, but for me, there were these moments where it would just grab me and pull me in and go, no, you're not going to listen to this in the background. You are going to pay attention. I am going to take you on a journey. I'm going to bring you in. And I think a lot of that has to do with how it was mixed. I think some of it has to do with the reliance on weird sound effects. But also, I think some of it was like his use of counterpoint lines, which kind of reminded me of like Earth, Wind, and Fire September. Like you can't find the melody of September in any one instrument. It is an emergent property of the mix, and there's a lot of this that reminds me of that too. But the biggest thing that shocked me were the songs that I liked most in the speakers mix. Were not the songs that I liked most in the headphone mix.
Same for me. Yeah, that's we should point that out. You don't have to be a jazz fan to like this. You don't even have to be an audiophile to like this. I think like hip hop fans could use this as sort of chill music without vocals, and it's really cool. I think it's one of the best things David's ever done. And David's been recording, like I said, for 40 years. And David does, David writes operas, David writes symphonies, David writes music for commercials, David writes all sorts of stuff. And this is just way, way, way cool. And this is like the most exciting thing. This is probably going to be the most exciting audiophile event that's going to happen this year, I'm guessing.
Do you have a favorite from the album, by the way?
Number 3, whatever that. And the songs are not even titled. It's just, Graffiti Jazz number 3 or whatever, right?
Yeah. If I'm listening on my speakers, if I'm listening on my like sort of 2-channel setup, my favorite, I think, was number 5. Because it was this weird moment where I'm listening to it and I'm like, you crazy son of a gun, are you using reverb as an instrument here? It's kind of weird. It's like the percussion is tuned. It's just a neat experiment in sound, but it's a journey. It forces you to take a certain journey through the mix. And I have to say, my journey through the same track can be different depending on when I listen to it, what mood I'm in.
So should we stop dancing about architecture here and actually play some of David's stuff for people?
Yeah, let's play some of it.
Okay, good.
I think we'll use the speaker mixes, I think, because the speaker mixes sound good on headphones, but the headphone mixes to me don't sound great on speakers. So
I'll tell you what if we do a speaker mix for our first break here, and then for our next break, we'll do a headphone mix.
Oh, that's a great idea. Cool.
Let's do that. That's what we'll do.
Okay. Anything else we want to add about this one?
No, I'm done. People, we've said enough. It's time to go listen.
Okay, but people should also read your article, and we'll link to it in the show notes.
Yes, cool.
All right, well, we're going to take a quick break while this is playing out, and we'll see you in a bit.
Hey, we're back. This is Brent Butterworth and
Dennis Berger.
Yeah, you. Yeah, so we're going to talk about a subject that Dennis is, I think, a reviewer that goes the deepest on this topic, and it's a deep topic, but it's an important one. Dirac, which is an audio technology company, has announced the new Dirac Live Auto Target Curve. And I will just say real quick before I ask you any more about this, Dirac makes this technology that basically automatically corrects for your room acoustics and the flaws in your speakers and things like that, and makes the sound theoretically perfect. But Dennis, what does this mean that Dirac has a new live auto target curve?
Well, first, I would slightly disagree with you when you say that it's automatic. If you want the best results, it's not automatic.
Okay.
I mean, the thing is, just to explain to people what this is, you have a microphone. You place it at different positions around your listening position. You raise the microphone up, you lower it down. You take 9 measurements that are sort of going to be around your head or around the seating locations where you're sitting. And then Dirac analyzes that and basically sort of compares that to what it says should be the target sound. Okay. And it basically creates filters to correct for that. So if you've got really any big inconsistencies in your bass or things like that, it can even those out. And basically what it attempts to do is remove the distortion caused by your room before it reaches your ears. Basically, it creates a filter that is the inverse of that distortion. That's greatly simplifying it, but that's kind of what it boils down to. So anyway, in the past, I think a lot of people have criticized Dirac's target curve because it is a little light on the bass. But they've created this new sort of auto target curve where effectively it is going to, as I understand it, look at the natural response of your speakers in your room, right? Mm-hmm. And try to follow that, try to create a curve that follows the natural response as best as possible while removing any big peaks or in your response. And so it's going to be a little more natural sounding and your speakers are going to sound a little more like your speakers, just basically taking out the deleterious effects of the room itself.
By the way, we should say that this is a press release that went out. It's on audioexpress.com, but you can go to Dirac's own site, I'm sure, and find some information about it. It's DIRAC. Mm-hmm. And so, okay, so it's listening to the speakers. Is it sort of just like taking in the character of the speakers, probably like mostly in the mid-range and treble, I'm guessing, and then going like, okay, let's don't fool with that, but let's correct the problems it would be more likely due to room acoustics?
It doesn't do that. You can do that, though.
Okay.
One of the things that Dirac makes it really easy to do is set maximum filter frequency, and you basically just take a slider and go, nope, you correct just to here. Well, and actually, we should say there are 2 different versions of Dirac. There is usually when you buy a component that has Dirac built in, you've got your free version that comes with it, and that will only go up to, I think, 500 hertz. Mm-hmm. And then if you want to, you can upgrade to Dirac Live Full, which gives you full frequency response, 20 hertz to 20 kilohertz, although I never go that far. The only room correction system I can think of that I would run full range is Trinov. That's because of their microphone. But yeah, so if you know what you're doing, you can go in and say, no, only do the bass, right? Well, it's not just the bass, but it's mostly the bass. So
yeah. Do
we want to dig into like frequency zones in a room and explain what those mean to people?
Yeah. So the way I see it is like there's what's called the Schroeder frequency. It was first noticed by, not surprisingly, a guy named Schroeder. And everything below the Schroeder frequency, below that, sound operates kind of like it's your room operates as a resonator. Okay, like blowing across a jug, where you blow across a jug and it goes whoo, or a Coke bottle or whatever, right? And it resonates at a certain frequency. Mm-hmm. So your room has certain frequencies it resonates at, and really reinforces the bass, and then also kind of attenuates the bass at other frequencies. And also, this also varies depending on where you're standing or sitting in the room and where your subwoofer or your speakers are in the room. But above the Schroeder frequency, sound kind of acts like billiard balls on a billiards table, just bouncing around and reflecting around until it hits enough soft stuff and gets soaked up. So, and the Schroeder frequency is usually around for most rooms about 250 hertz or something?
Depends. Like in my media room, I think it's around 220. In a lot of rooms, it's around 200. It depends on the size of your room. But
yeah.
So one of the things is a lot of people, I think, for a while said, oh, given that, you should set your max filter frequency for room correction at the Schroeder frequency, which actually I think is wrong. And I should say, this is the way I do it. This is my opinion on this, given my understanding of room acoustics and sort of frequency zones. There's actually a frequency zone below the sort of resonant frequency. There's if your room has the right dimensions, you sort of take the longest dimension of your room, and any wavelength that's double that basically acts like a change in static air pressure. And then above that, you get into the resonance area. And then way above the Schroeder frequency, you get into the Ray region. But there's this third region that's a sort of a transition region between the Schroeder frequency and the entirely Ray region. So what I say is you should take the Schroeder frequency and go 2 octaves above that and set your max filter frequency there. So
2 octaves above the Schroeder frequency would be like 900 hertz or something in a typical room.
Yeah, 8 to 900 hertz, something like that.
And this is based on your experience, your subjective experience, right?
Correct. Absolutely.
Okay.
That's why I give that caveat. This is the way I do it. This is what I think sounds best. But I should say, this new auto target curve thing, that doesn't do that, right? It's sort of one of the complaints I got about it. It does sort of follow the natural response of your speakers in your room better. But here's the thing. If they're going to do that, there's so much. You can actually... Look, if you want to calculate the Schroeder frequency in your room, you can do math, right? Mm-hmm. Or you could look at Dirac, look at all of the measurements that it takes of your speakers, and you can, if you look at all 9 measurements for all of your speakers, you can sort of see right where your Schroeder frequency is, the crossover frequency, right? Because your peak-to-peak variations start to become less pronounced, and you could see it sort of transition, and you can't really see as well that sort of 2-octave transitional zone, but if you find that spot where basically you could see things are changing, the response of my speakers is behaving differently on the left side than it is from the right side. Find that point, go 2 octaves up, and that's where you'd set your max filter frequency. But I think if Dirac is building this sort of intelligence into their system now, into their app, I don't understand why they couldn't go one step further and sort of delineate those frequency zones to help people better and more easily find their sort of max filter frequency.
So you reviewed the NAD C399 integrated amp on SoundStage, and that has Dirac's target curves and NAD's own target curves that they came up with. Mm-hmm. And yet you didn't use any of them. This is on SoundStage Access. So, but you didn't use either of those curves. So why didn't you use the auto correction, and does it actually, I mean, is it worth doing if you don't use the curves?
Well, when I reviewed the C399, this feature hadn't come out yet. I think I wrapped up my review of that in December, maybe something like that. I mean, we have long lead times at SoundStage, so it's got to go to Canada to be photographed and measured and all of that. So it wasn't available at the time. But yeah, I wanted a curve that more closely followed the sort of average bass response of my speakers in my room, because well, I bought those speakers because I like the way they sound, right? I don't want room correction drastically changing them. And I felt that Dirac robbed me of some of the bass response of the speakers. And I felt like the NAD's target curve overemphasized the bass response. Not by much. It was closer. But yeah, basically what I've always kind of done is sort of something similar to what Dirac is doing now, which is like try to look through the errors and the problems that the room is causing and go, okay, no, here's what the bass response of my speakers wants to be in my room, minus those peaks and valleys caused by resonances, and follow that. So it seems like what they're doing here is something similar to that. They're just tracing what the natural response would be. And then they're allowing you also basically to just raise and lower the bass or the treble. You can go into sort of those 2 different zones and go, you know what, the speaker's a little too bright. I'm going to bring the treble down. And instead of having to draw a new curve, you can just sort of grab it and pull it down or pull it up or what have you. I like that.
Yeah. So does this? So I'm thinking maybe. So I've had a couple of objections to these things. Number one is you buy a set of speakers presumably because you like the sound of that set of speakers, and maybe you want to adjust things a little bit, but you don't necessarily want Dirac or Trinov or somebody like that, just saying, "Oh no, your speakers don't sound right. We need to change them." And so I think that's, I mean, you may want to. I mean, if you buy speakers that you don't end up liking, maybe you want to fix them. That's fine. But and then my other objection, I've heard two really well-voiced objections to the whole idea of auto EQ. One of them came from Paul Hales, who's a famous speaker designer we both know. Paul said to me once, he said, when you buy a grand piano, you put it in a room and you don't EQ the grand piano when you put it in your living room or on a concert stage or wherever. You just play the grand piano and it still sounds like a great grand piano, in all these different rooms. And then one time I was with Laurie Fincham, who is I think his title is Senior VP of Research at THX. And Laurie is one of the most legendary people in the audio industry, former AES president. He was the head of design at Harman for a while, doing like the Infinity line and stuff. He was the head of design at KEF for years and years and years. He's one of the people that really invented the digital fast Fourier transform speaker measurement methods that everybody uses now. And he's just this awesome dude. He's just so knowledgeable. And I was lucky enough to be sitting on his veranda at his house in Sonoma County, California. And so we're sitting there and he's talking about this. And he says, when we, and he also talks in this just awesome British accent, but he's like, we're sitting here on the porch and I'm talking to you and I hear your voice and you sound like Brent. But when we go get in the car in a few minutes, I don't think, I need to EQ Brent's voice to sound right in the car.
Right.
So I think that there are, 20 years ago, 15 years ago, when all this stuff came out, there were a lot of people that came out with this simplistic idea like, oh yes, we will just EQ everything to be flat and then sound will be perfect and we can walk away and we're all done for life. But that hasn't happened. No. So maybe this will bring us closer to that.
Yeah, I think a lot of the objections that you're bringing up are why I set maximum filter frequencies, right? It's again, my goal with Dirac, and I think I, accomplished this, and I talk about this in the C399 review. I wanted to make my speakers sound more like my speakers. I don't want the room resonances robbing me of the performance of what my speakers sound like, right?
Yeah.
And,
sure.
And again, one of the things we need to point out is that Dirac is not just EQ. It's a unique combination of finite impulse response and infinite impulse response filters. So, I guess the one objection that I have to what Paul said is, that's true of a grand piano, but speakers in a room don't radiate sound the way an actual musical instrument does, right?
Well, that's true. That is true.
Yeah, a lot of this is about, not only undoing the damage done by your room to your speakers, but also accounting for the fact that your speakers are interacting with your room because of the way they radiate sound. So it's kind of a combined thing. But again, to me, just my opinion, the most important thing to do is to tend to those standing waves and leave everything else alone. So,
well, I'm looking forward to reading your review of whatever first uses the Dirac live auto target curve, so I can get a better idea. I think it's live now. I think
I think if I still had the 399, I could do it, but I would only be able to do it with the mobile app, not the desktop app. It's not on the desktop app yet. So,
okay. Well, at some point you're gonna test this, and I'll read about it.
I can't wait to.
So, do you want to go listen to some more David Chesky music?
Let's do that. What did we decide? We're going to do a headphone mix this time.
We're going to do a headphone mix this time. So everybody put your headphones on. If you didn't have them before, unless you're in the car, don't put your headphones on.
I was about to say.
We are not responsible if you get arrested or whatever it is they do to people who wear their headphones in the car.
Yeah. All right. We'll see you in a bit. And welcome back to the SoundStage Audiophile Podcast with me, Dennis Berger.
And me, Brent Butterworth.
And for our last segment this week, we are going to be talking about a couple of articles that you sent to me, Brent. Mm-hmm. One of them from Audio Express called GaN Technology in Audio Power Amplification. And another one from Audioholics called the Peachtree Audio GaN 400, a new breed of Class D amplification. So what we're talking about here are amps that use GaN FETs instead of MOSFETs. Mm-hmm. And I'm going to learn some stuff from you this week because I don't really fully understand this. I mean, I kind of do, but not 100%. So we're going to talk about the use of GaN FETs in amplification, what it means, what are the advantages, and I'm going to let you kick this one off. Like, what?
Yeah, well, I should say
advantages.
I'm going to attempt to explain this to where it's not. This sounds like immediately I worry that people are going to tune out and go, "Oh, I don't understand." So this isn't that hard to understand, really. GaN FETs are gallium nitride field effect transistors, and MOSFETs are metal oxide silicon field effect transistors. And basically, MOSFETs have been used in audio amplifiers for, 30 years or something. GaN FETs are a new version, a new transistor that's more efficient than MOSFETs. And they also have like a higher maximum switching speed. Now, let me just explain to where these are going. So these are used in the power stages, the output stages of power amplifiers. Okay, so in a normal power amp, you have an input stage, which kind of takes the input signal and kind of processes it a little bit to where it'll work with the rest of the stages of the amplifier. Then you have a gain stage that boosts the voltage of the signal. Then you have the output stage, the power stage, and that's what supplies the current. That's where you get your big giant transistors that are like the size of a quarter, and they're about 3/16 of an inch high. The big silver things. Lots of people have seen those for years and years. So the way these transistors work is any kind of transistor works is you have some kind of they have three legs. They have a leg that is the control signal, which in this case is called the gate. And then you have a leg where the power is coming in, and you have a leg where the power is coming out. And so the control signal, which is, your signal from your earlier amplification stages, controls the amount of electrical flow that goes through the transistor. So with a MOSFET, with any transistor, some of the electrical flow is going to get chewed up in the transistor and wasted as heat. Okay, That's why transistors are on heat sinks. So MOSFETs are pretty efficient. I think they're about 85% efficient. So 15% of that current that's going through there is burned off as heat. GaN FETs are about 95% efficient, which means that only 5% of the energy is wasted. So what happens is the GaN FET can be more efficient, 10% more efficient. I can't calculate, but it's, significantly more efficient than a MOSFET. And then they also have a higher maximum switching speed, which means, in certain applications. So in audio amplifiers, the switching speed doesn't really matter that much. It depends on the amplifier. In a Class D amplifier, the switching speed is really, really high. It's at 250. It's at radio frequencies, right? In a standard audio amplifier, the switching speed is just whatever the audio signal is, right? So you're going to find these GaN devices probably mostly in Class D amplifiers because you're running the high switching speed and you're running a lot of power through them. And so I think that Peachtree Audio, as they said in the Audioholics article, has one of the first amplifiers out. It's the GaN 400, and it's really powerful. It's really compact, and with the GaN technology, because it's more efficient, you can make these devices a little bit smaller now. So you can make your amp a little smaller if you want to. But Stuart Yaniger for Audio Express really, I think, hit this completely out of the park. He's got a big, long, multi-page article. He tested a reference design from GaN systems. It's a little, so when manufacturers come out with a new technology or something, a lot of times they make a reference design that they can give out to manufacturers and go, hey, Sony or Yamaha or whoever, here's our device. You can test it, and then you can figure out how you can make it work in your own designs, right? So he's got this amplifier. He runs a bunch of measurements on it, and he really comes to, when I saw this, I'm like, well, what's a new transistor really going to do for the audio industry? Because we're running Class D. We're already pretty efficient. We're not, the audio industry doesn't have to chew up a lot of power. We often do with Class A amps and things like that, but we don't have to. And so I kind of thought, like, what's this really mean for us? But Stuart, I think, really kind of wraps it up beautifully, because he talks about, okay, great. So your MOSFET's 85% efficient. Your GaN FET is 95% efficient. What does that really mean? So if you have, amplifier A is a MOSFET, amplifier B is a GaN FET, and he says if you're running like 5 watts, typically might take 5 watts of power just to keep an amplifier on and running, right? So they're chewing up 5 watts of power even when they're idling. Okay, some of them chew up a lot more, but let's just say it's chewing up 5 watts. And he's saying you're running audio at 1 watt, which is 1 watt of audio is like what you're really listening to on a normal basis in your living room. You only need 1 watt with most speakers to get 88 or 86 dB, which is a normal listening level. So he's saying that, like, if you're running at that total amount of power, the total dissipated power from the MOSFET amp would be 5.15 watts, whereas the GaN FET amp would be 5.05 watts. So you're talking about 0.1 of a watt, a tenth of a watt power consumption difference, which is not significant. Really. I mean, that's not going to save you power. That's not going to allow you to shrink your chassis too much or anything like that. But he says at higher power, that 100 watts, though, amplifier A is going to dissipate 20 watts. That's the MOSFET one. Amplifier B, the GaN FET one, will dissipate 10 watts. So that's half the power when you're at high volume levels. Okay, so if in situations where the amp is running at home in 1 watt, maybe this doesn't have that much benefit for like audiophiles who generally don't use that much power, who generally are down in the 1 to 10 watt range. But it might have more applicability for, say, PA amplifiers. I mean, some of those PA amps are 1,000 watts, and they're driving these giant speaker arrays and things like that. And they're cranked.
Yeah,
they're cranking.
Yeah.
They're putting out colossal amounts of volume. So I think for applications like that where you're really cranked and really consuming a lot of power, maybe also certainly for subwoofer amplifiers where you
subwoofers, I was about to say, especially with home theater.
Then you're hitting, I mean, for most of the time, you're not chewing that much power up, but for midway, when you're watching the battle scenes, you're going to be hitting 100-watt peaks easy, and maybe 400-watt peaks. So, and then also, I think that this is why I assume they've really taken off with the wall wart market, with the USB charger market, because the charger's running kind of full out all the time, right? It's running at whatever voltage. Now, it's not, if you don't have anything plugged into it, it's not really consuming that much voltage, but assuming something's plugged into it and charging, you're running kind of full out. You're running somewhere at some fairly high consistent level, with DC voltage, consistent output, which is in audio, you don't have consistent output. It's like nothing, and then it's like 100 watts, and then it's a fraction of a watt in the course of 1 second. Yeah. So I think for those things, for really demanding audio applications where you're really running high volumes and high output levels, and also for chargers, it's going to make a difference. I'll be curious to see, though. I mean, I'll be curious to see if more of the subjective review crowd listens to this and says, oh, GaNs sound better, or GaNs sound worse, or GaNs don't make any difference, or who knows what. It's very hard to predict what they will say. And I'm going to pontificate here, or prognosticate, or something beginning with a P. I'm going to say that I will guess that somebody will say this sounds better than MOSFETs.
Let me ask you this. I'm going to show my ignorance with this question, but we're talking about, these GaN FETs in a Class D scenario, and Class D amplification. I think there's a lot of misunderstanding about Class D, even amongst people who really get it. They think it's digital. Well, no, it's not digital. In most cases, it's pulse width modulation, right? So with the GaN FETs, do you think with that, since they have a faster slew rate, would that affect switching noise, do you think?
Well, here's the thing. Okay, so switching noise, we should say, in any kind of Class D amplifier or in a wall wart charger, because they all all those wall wart chargers that you buy now are effectively Class D. And they work pretty much just like Class D amplifiers. They switch on and off really, really fast, and then they filter it to where it's at whatever frequency you want, or it's just, or it's DC. But the switching noise, I think, is the problem that they had a lot with a lot of the early Class D amplifiers is, you have this, unlike, say, your radio receiver, where, you have, whatever high frequency energy is in there. It's at very low levels in a radio receiver, but it still radiates, and that's why you couldn't bring like radio tuners on airplanes, right? But, there's a big difference between radiating at a fraction of a watt versus, radiating at 100 watts or something. So a lot of these early Class D amps gave off, they were radio transmitters, basically at whatever, with a Class D amp, I should say, the way it works is you have like a 250 kilohertz carrier signal going in there, but by combining it with the audio signal, you get the pulse width modulation that you were talking about, where you have bigger, shorter and longer pulses, but they're all at full power. But at the you're getting a radio frequency signal, but then you run it through a filter that filters out all that high frequency stuff, and you get an audio signal magically. But since you have these output transistors running at 250 kilohertz at really high power, it's just a radio transmitter. Okay. Now, I remember when they were doing, like Pioneer did the first THX certified Class D amp, Class D receiver, in fact, about, I want to say 10 or 12 years ago. And they had, I know they told me they had a lot of problems. Both Pioneer and the THX people told me they really had difficulties getting the radiation down. And so it's not radiating, RF all over the place, which might be a problem for some audio situations, but also could interfere with your other radio frequency devices like your Wi-Fi or whatever else you have in the home. And I don't know the specific engineering on this, but nobody talks about switching noise anymore. Nobody talks about problems with Class D amplifiers having switching noise. So I assume this problem has been solved through shielding or who knows what, or maybe switching to different frequencies. So I don't think that, and I'm not an expert on this. I've read enough about it to understand how it works, but I don't think that the higher switching frequency on these, at least for audio applications, is going to make any difference unless you want to start doing, octuple rate DSD or something crazy like that.
Yeah. I mean, I think one of the biggest advantages that I can see in this, and I'm not discounting the efficiency. That's cool. I'm all for reduced power usage, no matter how little it is. But for me, there are very, very high end audio enthusiasts whose opinions I respect very much, who wouldn't touch a Class D amp with a 10-foot pole. Sure. And I think one of the cool things about things like the GaN FET technology and, we were talking about the NAD C399. It uses Hypex's N-Core architecture. I think the cool thing about new advancements like that, well, I have to say that NAD sounded incredible, but I think more importantly, what it does is it perhaps causes people who are like, oh, Class D is horrible, to go, oh, well, there's this new technology that fixes all of the problems. No, like, forget whether the problems have already been fixed, but they're like, oh, I'll take a listen now, right? I'll take another listen to, this is what's going to prompt me to listen to Class D again and finally accept it. And, for me, I think the more people using Class D amps, the better. It's better in terms of power efficiency. And it's also, one of the things I found is a lot of the new Class D architectures that are out there are just not as influenced by impedance swings and electrical phase in larger speakers as older amp technologies are.
That's true. So, that's a good point, though. So much of audio technology is as much a marketing exercise as it is a technology exercise. And if you look at DSD, the Sony Direct Stream Digital audio format, which is basically pulse width modulated. It's Class Class D is pretty much the same technology as DSD, but DSD is revered by audiophiles as being more analog sounding somehow.
Right. And then they say that the Class D is more digital.
Class D is more digital. And, I asked when I was at Dolby Labs 20 years ago, I remember my total technical guru there was a guy named Roger Dressler, and Roger just knew everything. He's just a brilliant guy. And I was so frustrated because we were selling DVD audio, which was PCM audio, and Sony was pushing SACD, which was DSD audio. And I read the technical papers on this, and I'd be like, this isn't better, and you could argue in certain ways it's worse, and I don't understand. And plus, it's the same. It's basically the same as Class D, which was just coming out then. And why are audiophiles saying that this is somehow more analog? And Roger just pauses for a second, and he says, well, it's because they've been told by Sony that it is.
The argument that I have heard, interestingly enough, is that if you, and I don't know how this makes sense, if you can figure it out, please explain it to me. But it's like you can look at PCM and it doesn't look like sound, but you can look at pulse width modulation and it looks like an analog signal. And I'm just like, meh. What?
No, it looks less like an analog signal because it's all ones and zeros. Yeah. There's no, whereas PCM on the bit level is all ones and zeros, but on the byte level, it's samples. Every sample means a certain audio level, right? So you can look at the samples and they represent specific voltages, whereas DSD doesn't mean anything until you filter it off, until you put it through something else.
Yeah, I've heard people say, "Oh, you can look at DSD, you can look at a read out of it, and you can see the music." No. And I just like puff pass, dude. I need some of whatever you're smoking because I don't get it.
That's just it's just so crazy. It's just so absolutely crazy, and that's why I always say there's a lot of things I always say, Dennis, and there's a long list of things I always say, but I always say one of the many things I always say. And now I've forgotten what it was. Oh,
you forgot to take your meds, didn't you?
Yeah, I did. One of the many things I always say is that you should learn rather before you actually form opinions about audio. You really should learn, just get the basic technical understanding of it. Go to the Wikipedia page or read a book or something like that and try to understand the technology, not from the standpoint of some audiophile explaining it or some reviewer explaining it, but a really straightforward engineering explanation of it, and then go to the audio forums or then go read the reviews and see what the reviewers say. But come into it with some basic technical understanding. Otherwise, you are not armed. You are pretty much helpless in like the stream of just nonsense that so often comes through on audio forums and in reviews. Because the reviewers quite often do not dig deep on the topic. But if you want to, so Audio Express, sadly, it's like a $50. I write for Audio Express, I should say. But it's like a $50-something subscription, so there's no cheap and easy way to do it. And to get on their website, you have to be a subscriber. But it's worth checking out. You could probably get a sample issue or something for free. I don't know, but it's worth checking out. It's really deep dives on all this stuff. And I got to say, a couple of the things are way over my head. But a lot of the articles are just really nice and clean. This one by Stuart Yaniger is just perfectly explains the whole GaN thing, and the job is done. And he just did such a great job, and I'm just so thankful for this. I'm so thankful to come into the GaN thing just as I was becoming aware of it. Literally, I didn't know what they were until like a month ago, and to find this article and go like, oh my God, it's all explained. I'm done. It's such a relief, as opposed to waiting years to understand something.
I wish he would do a similar explainer on that HyperX Encore technology, because I had to admit in my NAD review, it's like, look, guys, I've read the white paper. I barely understand. I could not explain this to my dad. And that is sort of my baseline for whether I truly understand it. Yeah. I was like, all I can do is tell you what I'm hearing. I don't really understand what's going on here. I mean, look, we don't have time to understand literally everything, but you're right. Some baseline understanding would it would dispel a lot of ignorance, wouldn't it?
Well, look, maybe somebody, I don't know who, not me, but you or Jeff Fritz or Doug Schneider or one of the SoundStage writers will dig into this topic the first time we review a GaN amplifier and do a nice little technical deep dive, and maybe I'll send them this article and they'll be well informed. as opposed to reading the manufacturer's marketing stuff written by somebody who may or may not understand the whole GaN thing, and quite often written by ad agency people who don't understand any of this stuff. But I'm confident that SoundStage will do. I hate to be so self-promotional, but I promise. I'm pretty sure we'll do our best. So
I love to be self-promotional.
Yeah,
I think that's a good place to wrap up for this week. Did we make it through a whole episode without seriously pissing anybody off?
Oh, who should we go after now? Who should we go? Yeah, normally we're just like, oh, well, sorry for all the people we criticized, but I'm sorry to our listeners for not being more snarky. I promise we'll double up on the snark next week. I promise.
No, we'll double down on the snark.
Okay, whatever as you kids say.
Yeah. Do you want to do some credits?
Yeah. So my name is Brent Butterworth, and you are?
I am Dennis Berger.
What did you do for this podcast?
Well, I definitely did the sound engineering and the editing. One of us will do the mixing and mastering, I'm sure. We've sort of been punting that one back and forth.
Probably you.
Probably me. Who did the music, though?
I think all the music is just me solo this time, but
except for the breaks.
The breaks were all done by David Chesky, and I don't think David Chesky used any other musicians on this because it's all samples and it's all him sitting in his little room in his New York apartment banging this stuff out.
Yeah.
But it sure doesn't sound like that.
No, it doesn't.
So are we part of some organization here?
We are. We're part of the SoundStage Network, a collection of 9 microsites that cover all sorts of audio topics. Yeah, I think that's it.
Okay. Do we have to thank anybody else or acknowledge anyone else?
Not that I can think of. Can you think of anybody?
No, we should thank our dogs Bruno and Missy, for the emotional support they give us.
That's true. And Bruno is really wanting to talk to you right now. He hears your voice leaking from my headphones, and he's like, "It's Uncle Brent."
Well, I hope I'll be able to talk to him. Missy's sleeping on the couch as usual, ignoring everything going on.
Yeah. All right. Well, I guess we'll wrap it up, and we'll see you guys in a couple of weeks.
Okay. Bye-bye.
Bye.